Okay, so welcome to the class for modern manufacturing processes and course number ME6601. The total credit hours 3 hours. That means we need to have three classes in a week. Actually, in the case of master's course, we don't actually follow the strict rule. There are many other ways to conduct the classes. It can be it's not only the lecture. There can be tutorials and assignments and all of the other things involved with these credit hours. So it's not like 3 hours has to be the class time. Okay, the course content. This is a consolidated course content. In here, there are 4 major classes of will be held in this modern manufacturing process class lecture. First one is glassworking. Actually, in the undergrad level, we don't study all these things. That's why I included them in this lecture, in this course in the masters. So in the glassworking, we'll study how glasses are manufactured, all other processes involved with it, its ingredients and other things, and what are the heat treatments which are done in the glassworking industries to make the glasses stronger and tougher. And in the second, we'll study plastic processing. That means there are a lot of application of this plastic processing nowadays. I think you will not get a single house where there is no plastic. Okay, so it's a very important topic, and how these plastics are made. We'll study about this in the plastic processing and how these processes can be improved. What are the design criteria for the plastic processing? All other things involved with the plastic industry. And third one is the composite processing. This is kind of advanced technology. This is not much available in Bangladesh. Nowadays, some of the industries is trying to adapt it, but due to the high manufacturing cost, people are trying to avoid at this moment. But in future, it will composite will be the integrated part of our life. And number 4 is the rapid prototyping and additive manufacturing. This is the hot topic. If you want to apply for a for master's or PhD project, then if you choose this field like additive manufacturing or rapid prototyping, this is a very interesting and growing field in the case of research. And in future, it has many applications we'll be observing. So these are the 4 things, major things I will be lecturing on, and also the teaching methods are like lecture, guest lecture. I'll try to arrange a guest for this modern manufacturing process class, who will conduct the classes for you to give you some industry experience, because I'm a lecturer from the beginning of my career, so I was not involved with all these industries, or I don't have any industry experience. So if there is someone I can manage, then I'll try to contact him to give a lecture about to give you the industry experience. And the assessment method 4 actually. One of them is presentation, assignments, quizzes, and final exam. I'm not weighing this actually, how much percentage is involved in which one. I'll decide about it in later, how many marks will be in the final exam and how many marks will be in the quizzes, so that you get the most out of it. Most benefit would be yours. The reference book is mainly, I'll follow the Mikkel P. Gruver 2012 Wiley publication, and Fundamental of Modern Manufacturing Process, Modern Manufacturing Material Processes and Systems. This is the main reference book. And for additional reading, you can for additive manufacturing technology, rapid prototyping to direct digital manufacturing from Springer 2010. You can also study that for additive manufacturing. And for injection molding, there is a practical guide which gives kind of good insight for injection molding. So you can also follow that one. But mostly we will follow the Mikkel-Pick Gruber, the fundamentals of modern manufacturing. These are the main reference book. And before going to the lecture, I want to give you another overview how this course will be conducted. So first, I need to share a screen, another screen. I'll also share all this material with you, so don't worry about this. Course content, I've already talked about that, and the presentations that I was talking about is powder metallurgy, ultrasonic, and water jet machining. Actually, these are the things. These are the things that you have to present to complete as part of the completion of this course, sheet metal working, robot manufacturing. And what I have done is that I have distributed all these topics to all the students. I think there are 19 students in this course. So I try to distribute these 10 topics to 19 students. Just a second. Okay, so for the presentation, this is the presentation distribution. The first one is Mohammad Burhanuddin and Abdullah. You will be conducting a lecture. I mean, there will be time of only 25 minutes for each person. So altogether, it will take 50 minutes to give one lecture about powder metallurgy. So you have to prepare the presentation in such a way that since 2 persons are involved in one topic, then you have to ensure that there is no duplication. Okay, so you have to ensure that you have to discuss among yourself to what topic will be included in your presentation. So, or you can also share your presentations so that there is no repetition in your presentation, and there will be a strict time of 25 minutes. And there is also marks in the time management. So the marking strategy at the first, it will be like quality of PowerPoint slides, like 10%, time management 15%, and presentation 65%, question and answer 10%. Okay, so you have to keep this marking strategy in mind while you are preparing your presentation. So today is 5th of October. Okay, Abdullah.
জি স্যার।
কিছু বলতে যাচ্ছিলেন?
স্যার আমরা কি দুজনে একসাথে এটা?
একসাথে না, দুজন আলাদা আলাদা প্রেজেন্টেশন হবে পাউডার মেটালার্জির উপরে। দুজন টিম ওয়ার্ক করে ফাইন্ড আউট করতে হবে যে হচ্ছে কে কোন অংশটুকু করবে।
আচ্ছা আচ্ছা।
কে কোন টপিকগুলোর উপর বেস করে প্রেজেন্টেশনটা বানাবে। ইচ পারসনকে 25 মিনিটস টাইম দেওয়া হবে। 25 মিনিট তাকে প্রেজেন্টেশন করতে হবে, তারপরে কোশ্চেন আনসার।
ওকে স্যার, ঠিক আছে, থ্যাংক ইউ।
টাইম যেন 25 এর বেশি না লাগে, আবার হচ্ছে কম যেন না লাগে, এরকম খুব ভিডিও যেন শেষ হয়ে না যায়, এরকম যেন না হয়। টাইম ম্যানেজমেন্ট
আচ্ছা
also another skill. So
জি স্যার, জি স্যার। ওকে, ঠিক আছে স্যার।
The first presentation is for Burhanuddin and Abdullah. Burhanuddin কি আছে?
বুরহানুদ্দিন মনে হয় নাই আজকে।
জি স্যার,
আসছে, চলে আসছে।
বুরহানুদ্দিন আছে, তাহলে ঠিক আছে। তোমরা দুইজন মিলে প্রেজেন্টেশনটা রেডি করতে হবে এবং 20 তারিখ টাইম কখন প্রেজেন্টেশন, সকালের দিকে। আচ্ছা, একটা জিনিস আগে ডিসকাস করা দরকার আমাদের, আমি একটু পজ করে দিই। ওকে, আজকে আমরা ফার্স্ট যেটা শুরু করব সেটা হচ্ছে যে গ্লাস ওয়ার্কিং নিয়ে আজকে কথা বলবো। So these are the glass products. I think everyone is aware of these things. Like a lot of laboratory equipments are made of glass. Sometimes the decorative tools or tea table or decorative items are made of glass, windows, doors, and most importantly, the screen of the mobile phone. Right?
Yes, sir.
এটা নিয়ে সবাই চিন্তিত থাকে আর কি, কখন যে ফেটে যায়। So Glass. What is glass? Glass actually it's an amorphous solid. So what is amorphous solid? Amorphous solid হচ্ছে যার নির্দিষ্ট কোনো স্ট্রাকচার নাই। আমরা জানি যে all the materials are most of the materials in the available in the environment is crystalline structure. That means it has a regular arrangement of atoms. Just like, for example, if we look at the salt, sodium chloride, we'll see a regular structure. But in the glass, it does not follow any regular structure. These atoms are scattered and bonded together, but scattered. Not any regular. There is no regular formation. So there are some other metal alloys also which have this amorphous structure, and also some polymers available which also have this irregular structure. So all these things like the glass, polymer, and metal, which does not have any regular atomic arrangement or any irregular unit cell. If we go to the metallurgy, it doesn't have any crystalline structure, then it is called amorphous solid. The glass is one of that. And another thing about the glass is called super cool. The glass is super cool. Actually, that is cooled at a rate too high to allow crystal to form. That means when if you have studied metallurgy, then you see in the phase diagram the liquids first. If the metal is cooled slowly from high temperature liquid, then we will notice that the atoms lose their potential kinetic energy, and then they start to come together, and then they form the crystals. They form unit cell and then nuclei, and then that turns into the crystal. But in the case of glass, in the case of metal, if you cool it very quickly, for example, if we talk about hardening of steel, okay, then in the case of hardening of steel, what we do is we heat the steel at a temperature to form austenite at around 800 to 900 degrees Celsius temperature, and then we suddenly cool it to the liquid bath, or that means salt bath, to get the highest cooling rate. Okay, and that is why when we harden the steel, it does not have any regular structure. The structure that forms due to the hardening of steel is called martensite, okay, which does not have any regular structure. That is cooled at a very high rate. And what happens in the case of glass is that when glass is cooled to the room temperature, it behaves like that martensite, which does not have any regular structure, and it is cooled so fast that it does not have time to form the crystal. And it is not impossible to form glass, the crystal of the glass, but in that case you have to cool it very slowly. It's very slow cooling will give you the crystal of glass. But in the case of regular glass, there is no no regular arrangement of atoms. And one of the example of amorphous alloy which is commercially available in the market is made glass 2826. It has a composition of iron 40, nickel 40, and phosphorus and okay. So what are the ingredients of in glass? The ingredients mostly is silica sand, that is around 72% of the glass is silica sand, and soda ash is 17%, and lime soda ash is sodium carbonate, and lime is calcium oxide is 5%, and other things like potassium oxide, sometimes other aluminum oxide or manganese, all other oxides are available, but these are very small amount of them. The mostly is silica sand. Process sequence of glass working. The glass working process involves that means how glasses are produced. That is what we are talking about. So firstly, the silica sand, limestone, and soda ash, all these things are mixed together with proper proportion. Okay, the whatever proportions we need to manufacture the final to get the final property of the glass. For example, if I want to use the glass for the window purpose, then I will have a different composition when I am going to use the glass as a screen of the mobile phone. Okay, so it will be different composition and different heat treatment will be involved. So first, if we talk about the general manufacturing process, then we'll say all the ingredients are mixed together and then heated at about 1300 to 1600 degrees Celsius temperature to make it a liquid. Okay, and then we use Bangla যেটাকে বলা হচ্ছে forma. Okay, we use a mold to get the desired product of different shapes and sizes. Okay, the shape and size of the glass depends on what type of mold we are using for the manufacturing. That means what type of বাংলায় যেটা বলে সাস বলা হয় অনেক সময়, যে সাসের মধ্যে আমরা ফেলবো এই লিকুইডটাকে, মোল্ডেন লিকুইডটাকে, সেই সাসের আকৃতি সে ধারণ করবে। ঠিক আছে, এটা জাস্ট কনভেনশনাল ওয়ে অফ প্রোডিউসিং গ্লাস। The shaping, in the case of shaping, there are some processes involved, like you can use casting, you can use press and blowing. I'll talk about all of this to produce bottle and containers, and rolling to make plate glasses. Sometimes we also need reheating after manufacturing a certain part using the glass, and due to the uneven stress distribution and uneven cooling in the part, we need to reheat it to get better performance in terms of strength and temperament. Okay, that's why sometimes reheating is also required for final product, and also for the finishing or transparency we need reheating. And for safe handling is the general procedure, like 30 minutes you have to wait for cooling of the final item, and then you have to handle it. And the glass products are then decorated, inspected again, and finally packaged. So do you have any question till now?
No, sir.
So the second, raw materials, how to prepare the raw materials and how to do the melting. First, the main component is glass. That's what we talked about. This is silica. Silica, that means silicon oxide or sand. Sand has to be washed and classified. There's two terms. One is washed. That means you have to remove all the clays and greases or all other foreign materials with the sand. You have to remove them and get the pure sand, which contains silica only. And then classified means you have to find out the desired particle size. The best particle size for making glass is 0.1 to 0.6 millimeter. So you have to use kind of a strainer to get 0.1 to 0.6 millimeter diameter range of sand particles. And then you have to add various other components. That's what we already talked about, okay, in proper proportion. And sometimes recycled glass is also used, added to the mixture in modern practice. That's why you have to use recycled glass to get rid of waste, actually. And also sometimes in some industries, all of the final products of glass is made from recycled glass. Okay, in that case, if you look at the local hotels, you see the glasses in a different color, and you'll see some bubbles in there. You'll see some and doesn't have much temperament. In that case, those are actually manufactured using recycled glass. And there's 4 types of glass melting furnaces. One is pot furnace. Pot furnace means it's a kind of batch process. You are using a ceramic pot, okay, a large ceramic pot to melt the glasses, and then you put the molten glass into the various molds to do the casting. Okay, and the second one is the day tanks. It is kind of a larger capacity vessel. Okay. And third one is continuous tank furnace, long tank. It's a long tank. At the in one end you insert all these ingredients, and on the other end you'll get the liquid. It's a continuous process. Okay, you'll get the liquid glass, and then you can make your desired product. And then fourth one is the electric furnace. Okay, to heat the glasses and melt them. The melting cycle is typically melting cycle of a typical charge takes 24 to 48 hours. Charge means the mixture of soda ash, limestone, aluminum oxide, potash. This mixture in proper proportion is called the charge. The typical charge for melting typical charge it takes almost 24 to 48 hours for melting those. And then the temperature at which glass is taken from the furnace is depends on the viscosity required for the subsequent process. That means if you are using, there are various processes of glass product making. First one I can talk about, like casting. For example, for casting you'll need huge amount of fluidity of the glass. Then you have to heat the glasses at a higher temperature to get high liquidity, because the viscosity of the glass depends on the viscosity. The viscosity of the glass depends on the temperature. If you raise the temperature, then viscosity will be decreased, and it will be more liquid and it will be more suitable for casting. And if you are talking about like for cold pressing or blow molding, then you don't need a complete liquid. You can just heat to a certain temperature and then get it out with a certain viscosity to do the blow molding. I'll talk about the blow molding in the later slides. So the temperature at which you are going to take out the molten glass depends on the viscosity required for the subsequent process. Subsequent process means those casting or rolling or hot pressing. Okay. The shaping of glass, how to shape, that means produce the different kind of products. There are three categories available. One is discrete process. The discrete in the discrete process you produce piece ware, okay, which include the bottles, light bulbs, and other individual items. Okay, whatever the items you want to produce, if you produce one by one, okay, then it's a kind of discrete process. And continuous process means you produce something continuously, like a bar, or maybe it can be a tube, long tube, okay, or it can be the window glasses, it can be flat plate of glass, it can be windshield of the car. Okay, so these are the things that that can be produced continuously, and you can cut them off at a certain length. Okay. And third one is fiber making process. I think everyone is aware of the glass fiber. It's mostly used for insulation purpose, and also used for fiberglass composite manufacturing, for manufacturing the composite materials using this glass fiber, which is another name of fiberglass is glass fiber. The fiberglass composite is also used like randomly distributed glass fibers. We'll also talk about this fiber making process in the coming slides. Firstly, we'll talk about the shaping of piece wires, how to produce the piece wires. First one process, this process is called spinning. I think everyone in the production process or the manufacturing process in the undergrad level, we discussed about the centrifugal casting process. This is exactly same as the centrifugal casting process. In this process, what happens is that you put a hot gobe of steel, so gobe of hot glass in a steel mold, and then you rotate the mold. If you rotate the mold due to the action of the centrifugal force, this molten glass will be distributed evenly around the shape of the mold. If you keep a different shape in this place, for example, this one, so for example, this one is a conical shape. If your mold is like this, then you'll get like a ball. Okay, so whatever the size of this or whatever the shape of this mold, you'll get that shape with the uniform thickness of the glass material, and it is happening due to the action of centrifugal force, which is acting outward in the outward direction. Okay, so do you have any question on spinning?
No, sir.
Okay. This process is exactly same as the centrifugal casting, which we have studied for the metals. Okay. Next one is pressing. Okay. For the mass production of glass pieces like dishes, breakwires, TV face plates, similar items which are relatively flat, but it's not complete. It's not like the first one, like spinning. This kind of long structure. if you want to get relatively flat structure, then this pressing process is much useful. One of the example is here, like for example, if you want to make a glass plate, then you have to make a steel mold of the same size and shape of the steel plate, and then you put the gob of molten glass into this mold, and with the help of a plunger you press it and you get your desired shape after cooling. Okay, and this process is highly automated. You get the gob of the glass from the furnace and put it in here, and then this presses and allows cooling water flows through the molds, and then we produce the glass plate. Third one is blowing. Blowing is also similar to the plastic injection molding. In the case of plastic injection molding, if you want to produce the plastic bottles, then you have to go through two different steps. First one is to produce a small glass of plastic, and then you blow it to manufacture the final glass. And it is kind of similar process. First, you get the gob of glass material, molten glass, in a mold, and then you use the plunger to manufacture this kind of structure. Okay? And then use this structure to fix in the proper position, and then use air flow to hot air flow to the container with the pressure of air. This conical structure actually forms, gets aligned to the mold, and then this mold is separable. It has a parting line, and it can be separated from both sides, and then if you get, after cooling, you get the final structure. Okay, any question?
No, sir.
Blowing
Sir,
has
I am little bit confused about how the blowing is.
happening.
Sir, please can you say again how the blowing is happening? I'm little bit confused.
The first actually, this is we make a kind of the conical structure for the blowing operation. We put this structure in this place. This is another mold. This is at the first mold we get a triangular structure. Okay, and then we transfer that triangular structure into another mold, which has our final shape of the shape of the bottle. Okay. And then with the help of neck ring, we place this one here, and then we blow air. Okay, we apply the air pressure in that place, so that this glass is not a solid. Okay, it's not still solid. This glass is still in the plastic state, and then when we apply the air pressure, then this structure elongates and sticks to the surface of the mold. Okay, with
Sir, I understand. Thank you, sir.
uniform distribution of the glass. And sometimes we should also keep in mind that sometimes with this process, at the first step, if the temperature is too low, then it becomes solid. Then if you blow air, it will not expand. It will not expand and stick to the mold surface. Okay, in that case, we need a secondary heating of this this conical structure. Okay, did you get it?
Yes, sir. Thank you, sir. I get it.
Okay, blowing, there is another method which is called blow and blow method. This one is press and blow method. In the case of first pressing to make a small structure, conical structure, and then we get the final structure. It's not like it's not a concrete decision like in the 2 step it will be completed. Sometimes it requires more than 2 steps. Okay, you should keep it in mind. And for the blowing, it's 2-step blowing. Okay, at the first step, you put the gob in there, gob of glass in there, and then you put the covering of the mold, and then you blow air to get initial structure. Okay, then you transfer this initial structure to the final mold, and then you do the blowing again. Okay, in the 2 step. At the question could be like, why don't you do all this thing in the final structure? Okay, we can't do it in the final structure because for the large structures, large bottles like this, if we do the blowing at the initial stage to the we put the gob of glass in here and then blow it in this at this stage, what will happen is that the glass is amorphous. It does not produce any crystalline structure, so the glass will be separated. That's why we need several steps to get the final structure. Okay, it can be a question. Okay, it can be a quiz or sometimes the Viva question, like why we use multiple steps to manufacture the glass products, because we have to take care of certain things like it does not break. Okay, it doesn't get separated. Since it doesn't have any regular structure, it can be separated at any time. Okay, and also this type of structure in the during the processing 2 or 3 steps, if the glass product gets cooled and becomes solidified, then we have to do the reheating. Okay, final one for making the pitch wire is casting. Casting is similar to the metal casting. It's kind of similar, but in the case of glass, casting is mostly used for producing the large structures like astronomical lenses or mirrors. Okay, and these pieces are cooled very slowly to avoid the internal stresses. That means first you have to melt the glass, melt the glass to a sufficiently fluid state, and then you put them into a mold of the shape you want to obtain, and then you allow them to cool very slowly so that internal stress or no cracking occurs during the cooling process. After cooling and solidifying, you need to finish it up for the final application of this material. And the molten glass, the molten glass is relatively viscous at normal working temperature, does not flow through the small orifices and into the small sections. That is one of the disadvantages of casting process. Okay, for the glass, because glass viscosity of the glass is not like the liquid metal. Okay, it's kind of viscous, and that's why for integrated parts, if you want to produce like very small integrated parts, then it is not possible for the molten glass to reach in that small part of the mold. Okay, and smaller lenses are usually made by pressing. Okay, the pressing method that we have discussed earlier is used for manufacturing the smaller lens parts. Okay. Next is shaping flat or tubular glass. That means the continuous process. The method I'm going to discuss now is the continuous manufacturing of the glass products. The first one what I'm discussing is about forming the glass sheet. Okay, the glass sheet that we use in the window or windshield or door. Okay. This kind of glass sheet is produced. It's a very simple process. Okay, you melt the glass and then you pass that plastic liquid between the forming roll, and the gap of the roll will determine the thickness of the sheet, and the length of the roll will determine the width of the sheet. Okay, and then the liquid glass passes through the roller, and then you spray the water, cooling water into it, and then it becomes solidified and continuously gets out of the furnace. Okay, and if you can cut it at a desired length you want. And sometimes these are not the final product. This product has to go through the annealing furnace, because when the molten glass gets solidified using the external cooling, it has a rough surface, and then you have to do the annealing and cleaning operation, grounding and polishing to get parallelism and the smoothness. You have to get the glass sheets parallel from the both side, and also you need the smoothness of the glass. That's why you need some extra working, and annealing is required to get the uniform distribution of the glass, because when you are cooling at this point, when the liquid glass is getting out through the rollers, and at this point you're cooling, then surface gets cooled first and then internal structure gets cooled. So there is a mismatch that causes the internal development of the internal stress inside the glass. That's why we need to go through the annealing part, and the glass product needs to go through the annealing furnace to get the final desired strengthened structure. It's kind of continuous casting process. Do you have any question?
স্যার আমরা যে ফর্মিং রোলারটা ইউজ করছি এখানে স্যার অ্যাডহেসিভনেস এর কারণে কি আমার প্রবলেম হতে পারে না? এখানে তো স্যার যেহেতু
যাতে গ্লাসটা মানে রোলারের সাথে মানে অ্যাডহিয়ার হতে না পারে সেজন্য অবশ্যই তোমাকে এখানে লুব্রিকেশন ইউজ করতে হবে।
ওকে,
বুঝতে পেরেছো?
স্যার
আরেকটা কথা বলা হলো যে মানে রোলারের লেংথটার সাথে হচ্ছে আমার যে গ্লাসটা ফর্ম হচ্ছে সেটার হোয়াইটের সম্পর্কটা।
হ্যাঁ, if you want to make a sheet, for example, like this, make a sheet like this, the width, the thickness of the sheet. How do we determine the thickness of the sheet? In the case of continuous casting process, it depends on the distance between the rollers, right?
Yes sir, distance between rollers.
And how about the width?
This is the width.
Width depends on the width of the roller.
আচ্ছা আচ্ছা, বুঝতে পারছি।
Width, or you can also say the slot through which the molten glass is coming out.
Yes sir, বুঝতে পারছি। Yes sir.
Okay, any other question? Feel free to ask questions, okay? Because if you don't ask, you will not be able to answer, okay?
Sir, I have a question regarding the time dilation. So there is a required speed which should be maintained in case of time dilation. Because
yes, of course you have to maintain a speed. The speed at which you are taking the glass, solid glass out, you have to ensure the molten metal is getting into the system at the same speed. Are you talking about this, Rana?
So actually there is a temperature difference between the molten glass and the solidified form before and after the forming rolls.
Yep.
So we have to maintain some minimum time within the limit. So if we cross the limit, then it will solidify itself at the roller part.
It will be separated, right?
Yes, yes.
This one is solid. It will be separated. That's why you have to ensure the flow of the molten glass. Okay, you have to ensure flow of the molten glass. Otherwise, if the speed of the solid is greater than the available material here, then you will get a separation here. It will be separated, and then molten liquid will fall down through this way, right, Rana?
So yes, sir.
Okay.
How the cooling system actually works when it comes out from the roll?
Cooling system.
Yes,
Cooling system is basically spraying water.
Okay. Where should we apply this, sir?
It's kind of there are some nozzles. Okay, spray nozzles available in this part, which the water into the glass.
Okay, sir, is it needed to directly spray just after coming out from the rollers, or after?
No. Water is not coming out from the roller. The purpose of roller is only to provide the desired size.
Sir, I get it, sir. So, sir,
Sir.
I am not talking about the water coming out from the roller. I am talking about the position we should spray, the distance from the roller to the water spraying point, sir.
Distance. Oh, okay. Okay, there must be the water spray must ensure that you have to use the water spray in such a way. Not only the water spray, you can also spray the cold air. Okay, cold air can also be used to cool down the glass. You have to ensure that no liquid comes out of this roller.
So that will be a critical mechanical system or some advanced highly technical system to cool the glass when it's coming out from the rolls.
You have to do a lot of calculations, right?
Yes, sir.
At which
Understand.
point, at which temperature. It will depend on the temperature of the molten glass. If the temperature of the molten glass is a little bit higher, then your cooling system has to sense.
Yes, sir. I understand, sir.
Okay. Okay. Any other question? No. Okay. Then.
Sir, I have a question, sir.
Okay.
Sir, how to control the speed or mass flow rate of the molten metal through forming rolls? মানে স্যার কিভাবে স্পিডটা মানে মাস ফ্লো রেটটা কেমন হবে স্যার? খুব এটা কি এখানে কেন পাম্পের মাধ্যমে না স্যার নজেল বা রেটটা ফ্লো রেটটা কেমন হবে বা কতটুকু যাবে? হ্যাঁ,
ফ্লো রেট
কন্ট্রোল করবে কি?
হ্যাঁ, ফ্লো রেটের কথা যেটা বলছো সেটা হচ্ছে যে তোমার যখন এই মোল্টেন গ্লাস এটা যদি হচ্ছে তোমার কন্টিনিউয়াস প্রসেস হয় তাহলে সেক্ষেত্রে আমরা তিনটা পটের কথা বললাম না, মানে চারটা ওয়েতে মেল্ট করা যায় কন্টিনিউয়াস। কন্টিনিউয়াস প্রসেসটা যদি ইউজ করা হয়, আমি ইনগ্রেডিয়েন্ট একটা সাইড থেকে দিচ্ছি, ঠিক আছে, সেই ইনগ্রেডিয়েন্ট এক জায়গায় এসে মেল্ট হচ্ছে, তারপর সেই মোল্টেনটাকে আমি হচ্ছে একটা টেম্পোরারি ট্যাঙ্কে নিচ্ছি, সেই টেম্পোরারি ট্যাঙ্ক থেকে আমি হচ্ছে আমার কন্টিনিউয়াস শীট আউট করে নিচ্ছি। সো এই প্রসেসেস আর
মানে ফিডিংটা ওই সাথে সেম টাইম হবে ফিডিংটা।
এক্স্যাক্টলি, ফিডিং রেট যতটুকু থাকবে সেই রেট অনুযায়ী
ততটুকু আমার আউটপুট হবে। আচ্ছা আচ্ছা আচ্ছা।
এভরিথিং হ্যাজ টু বি ক্যালিব্রেটেড অ্যাকর্ডিং টু ইওর ফাইনাল রিকোয়ারমেন্ট। তুমি ফাইনাল রিকোয়ারমেন্ট কি রকম চাচ্ছ সেটার উপর বেস করে এটা হচ্ছে চেঞ্জ করতে হবে। ওকে,
জি।
এনিওয়ান এলস? Okay, moving forward, second process is the float process. Okay, in the case of float process, it's a kind of advanced technology is used in this case. Okay, in this case what happens is that it's also a continuous manufacturing process to produce the flat glass sheet. Okay, in this case what happens is that you control the flow rate on this place, in this place. Okay, the liquid molten glass comes out of this place and it spreads over the molten tin. The molten glass has a temperature around 1500 to 1600 degrees Celsius temperature, but tin has less temperature than that. But tin has higher viscosity than the glass. Okay, and that's why what happens is that the molten tin stays at the bottom, and there is a separate layer. The top layer is the liquid glass layer, and the bottom layer is the molten tin layer. The one liquid over another liquid. Okay, that's what happens in this case. And because of this liquid molten tin, the smoothness and the distribution of the glass, that means the parallelism and the smoothness, these two parameters are better compared to the first process that we have studied, the continuous rolling process. Okay, in that in this use of molten tin gives us more accurate dimension of the final product compared to the rolling method. Okay, and also the annealing process is required for both cases to get the uniform distribution of heat. And the molten tin bath, it's not like there are two zones actually. First zone is the heated zone, high temperature zone, and it's a controlled environment to get the uniform distribution. And in the cold zone, the glass becomes solidified, and then it comes out of the mold. Okay. Okay. Any question?
Sir, is there any chance to mix with molten tin and glass?
No.
No chance.
Because of the huge density difference, there is no chance to get. মনে আছে না যে একটা সমুদ্র যেখানে হচ্ছে
দুই রকম পানি
সেপারেটলি মুভ করে,
ডেনসিটির কারণে অ্যাকচুয়ালি,
and there is these two material does not react with each other, so there is no chance.
আচ্ছা আচ্ছা।
Okay, anyone else? Next is the glass tube drawing, how to make glass tubes. Okay, this process is also called Danner process. And in this case we produce the glass tubes from using the rotating mandrel. This is the mandrel. There is a hole inside the mandrel through which we pass the air, the cold air, and the mandrel is rotating continuously, and molten glass is poured on the mandrel. Then what happens is that due to the air pressure, there the internal diameter of the glass tube is formed due to the air flow through this mandrel, and it depends on the air temperature and its volumetric flow rate and the drawing velocity. That means at what speed we are pulling this glass out of the system. Okay, these three parameters determine the diameter and wall thickness of the tubular cross section. That means the air temperature and volumetric flow rate, how much air is flowing through this and at what temperature. Okay, এই দুটো জিনিসের উপর ডিপেন্ড করে যে ইন্টারনাল ডায়ামিটারটা কি রকম হবে, and drawing velocity, at what speed you are drawing this glass, and also the air temperature. Both these two parameter actually determines thickness of the glass tube. So what happens here is that the glass tube is continuously drawn using these support rollers. Okay, and molten glass flow, that molten glass is poured into the system continuously at the same speed. Okay, at what how much molten glass will be poured in this system will determine also the thickness of the glass tube. Okay, so all these four parameters has to be calibrated in such a way to get a desired product with desired internal and external diameter and thickness. Okay, major thing, and then you can cut it to the desired size you want. And most of the applications are in the laboratory glassware, fluorescent light tubes, that tube light use for thermometer and other things that are tubular. Okay, so any question on this one?
স্যার আমার একটা কোশ্চেন ছিল
বলো
স্যার, আমি বলবো স্যার।
হ্যাঁ বলো না
স্যার কোশ্চেনটা হচ্ছে স্যার এটার ক্ষেত্রে এবং ব্লোয়ার মেথড সেটার ক্ষেত্রে যেখানে আমরা এয়ার প্রেসারটা ইউজ করছি, আমরা স্যার জানি প্রেসার হচ্ছে দুই রকম, একটা হচ্ছে স্ট্যাটিক আর একটা হচ্ছে ডাইনামিক। তো আমি এটা বোঝাচ্ছি যে স্ট্যাটিকের জন্য সব জায়গায় প্রেসারটা সেম থাকতেছে, এই জন্য আমি একটা শেপ পাচ্ছি ব্লোয়ারে ব্লো প্রসেসের জন্য আর এটার জন্য। কিন্তু আমি যখন ডাইনামিক প্রেসারের কথা কল্পনা করবো, অবভিয়াসলি স্যার আমি যদি একটা এয়ার দিই তাহলে এখানে ডাইনামিক প্রেসারও থাকবে। তো তখন স্যার ইনার সারফেসের যে স্মুথনেস সেটা কি স্যার মেইনটেইন করা পসিবল এই ডাইনামিক প্রেসারের জন্য? কারণ ডাইনামিক প্রেসার তো স্যার সমানভাবে সব জায়গায় পাবেন
সমানভাবে সব জায়গায় পাবে না কেন?
কারণ স্যার এটা একটা ডাইরেকশন আছে, আমি হচ্ছে যে ডাইরেকশনে এয়ারটা ফ্লো করাচ্ছি সেই ডাইরেকশন বরাবরই আমি এয়ার প্রেসারটা পাবো, সাইড বরাবর পাবো না। বাট স্ট্যাটিক প্রেসার স্যার সব দিক দিয়ে সমানভাবে পাবো।
Let's say there is a tube, okay, and if you want to measure the pressure at this point, air is flowing, okay,
sir,
so what will be the pressure distribution? Air is flowing through this at certain volumetric rate. Okay, that means it's Q. Q is the volumetric rate, isn't it? Small
sir. এখন স্যার আমি কি স্যার অ্যানোটেশনটা ইউজ করতে পারবো?
হ্যাঁ, ট্রাই করো দেখি। আমি যদি অ্যাক্সেসটা
না স্যার পাচ্ছি না স্যার। স্যার আমি হচ্ছে এটার ব্যাপারটা হচ্ছে যে ফার্স্ট অফ অল আমার তো এই ব্যাপারটা থাকবে না, আমার তো স্যার হচ্ছে এই যখন এয়ার প্রেসারটা দিব তখন আমার হচ্ছে ডাইনামিক প্রেসারটা ইমপ্যাক্ট ফেলবে সলিড অংশে, যার ফলে ডাইনামিক প্রেসারটা এই হলো শেপটা ক্রিয়েট করবে, রাইট স্যার? তো স্ট্যাটিক প্রেসারটা আমার সারফেস বরাবর কাজ করছে, সেক্ষেত্রে প্রবলেম নেই, যেহেতু হোল সারফেসই সেম প্রেসার হচ্ছে সেটা প্রবলেম নেই। কিন্তু ডাইনামিক প্রেসারটা যখন রিলিজ হবে হোলটা হওয়ার সাথে সাথে এই যে প্রেসার ডিফারেন্সটা হলো, এটার ফলে কি স্যার আমার যে ভিতরে সারফেস স্মুথনেসটা সেটা কি ইফেক্টেড হচ্ছে না? অথবা স্যার আপনি হচ্ছে এই যে ব্লো প্রসেস যেটা আমরা দেখলাম সেখানে হচ্ছে সেম, আমরা যখন প্রেসারটা দিচ্ছি তখন যেই অ্যাক্সিস বরাবর প্রেসারটা দিচ্ছি সেই অ্যাক্সিসের পারপেন্ডিকুলার প্রেসারটা বেশি হচ্ছে, কারণ ওইখানেই আসলে ডাইনামিক প্রেসারটা ইমপ্যাক্ট ফেলছে।
তো ব্লোর ক্ষেত্রে ইট উইল বি ডিফারেন্ট, কারণ হচ্ছে কি তুমি যখন ব্লোর কথা চিন্তা করতেছো, ঠিক আছে, তখন কিন্তু তুমি আলটিমেটলি স্ট্যাটিক প্রেসারেই চলে যাচ্ছ। ব্লো হয়ে যাওয়ার পর এখানে কিন্তু সার্টেন টাইম তোমাকে প্রেসারটা মেইনটেইন করতে হচ্ছে, দ্যাট মিন্স স্ট্যাটিক প্রেসারে চলে যাচ্ছে তুমি। তখন হচ্ছে যদিও কোনো জায়গায় হচ্ছে বেশি থেকে যায়, ফার্স্ট হয়তো তোমার যদি এরকম কনিক্যাল থাকে, ঠিক আছে, এই কনিক্যালটা প্রথমে হয়তো গিয়ে কি করবে, এখানে এসে টাচ করবে ডিউ টু দ্য ডাইনামিক প্রেসার, তাই না?
স্যার
তারপর হচ্ছে এটা আস্তে আস্তে আবার এদিকে এক্সটেন্ড হবে।
স্যার আমি ঠিক এইটাই বলছি স্যার, যে ফার্স্টে যখন হচ্ছে ইম্প্যাক্টটা পড়লো মানে লম্ব বরাবর, এই জায়গা সারফেসের প্রেসার ইনিশিয়াল পর্যায়ে
সেপারেট হয়ে যাবে কিনা সেটা বলতে
স্যার এক্স্যাক্টলি স্যার, মানে এখানে তো ডাইনামিক প্রেসারটা বেশি থাকবে।
ডাইনামিক প্রেসারটা তোমাকে সেটা অবশ্যই এনশিওর করতে হবে যাতে হচ্ছে ইট ডাজ নট ওয়ার্ক লাইক অ্যান ইমপ্যাক্ট। ওকে, when you applying pressure, it should not be like an impact, and same happens in this case too. Okay, you don't apply your pressure suddenly. Okay, it's a continuous process. The air is continuously going through this tube, isn't it?
স্যার তাহলে স্যার আমার ম্যাটেরিয়াল প্রপার্টির সাথে আমি অ্যাকচুয়ালি এয়ার প্রেসারটাকে কমেন্ট করে নিব যে কতটুকু এয়ার প্রেসার দিলে স্যার ডিফর্মেশনটা হবে না।
No, it's not the material property, is it?
স্যার আমি যদি এর কথা চিন্তা করে দেখি, মোল্টেন মেটাল এবং মোল্টেন গ্লাসের কথা চিন্তা করে দেখি, তাহলে স্যার ডাইনামিক প্রেসার ইফেক্ট তো স্যার ডিফারেন্ট ম্যাটেরিয়ালের জন্য ডিফারেন্ট হবে, কারণ স্যার এটা ভিসকোসিটি আলাদা স্যার।
There must be some kind of optimization.
Sir.
There must be. I don't know much about pressure actually. I don't know.
Sir, so sir, we must have to avoid the impact.
Yes,
sir, কথা বলতে চাই স্যার।
If you do the impact, then you get separation. Okay. Who wants to talk?
স্যার একটু কথা বলতে চাই। স্যার ব্যাপারগুলো হচ্ছে যে এগুলোর প্র্যাকটিক্যাল ব্যাপারগুলো হলো এরকম যে প্রেসার গুলো অটোমেটিক্যালি, যেগুলো নিউমেরিক্যালি সেগুলো অটোমেটিক সেট করা থাকে, আর যেগুলো ম্যানুয়ালি কন্ট্রোল করা হয় সেগুলো ম্যানুয়ালি সেট করে দেওয়া হয়, যে এই হচ্ছে আপনার টিউবওয়েলের ক্ষেত্রে যে এত কেজি লাগবে, বা ওই যে আপনার যেগুলো ওই সেন্ট্রিফিউজিং এর ক্ষেত্রে এগুলো এত কেজি লাগবে, সেন্ট্রিফিউজিং এর ক্ষেত্রে স্বাভাবিক কম করে দেওয়া হয়, আর যেগুলো টিউবুলার সিস্টেম যে কোনো প্রোডাক্টের এগুলোর ক্ষেত্রে স্যার একটু বেশি দেওয়া হয়। এটা হলো প্রেসার ডিফারেন্সের ব্যাপার একটু।
তা তো অবশ্যই, আর যেহেতু এটা হচ্ছে একটা কন্টিনিউয়াস প্রসেস, at the beginning of the process you will have to use a solid up to this point, a solid tube up to this point, then you start the air pressure, the air flow, and then you start pouring the molten glass, and then you start cooling this one. Then air flow is continuous through this process, and it's a fully developed flow, so there is there is constant pressure gradient. Okay, so it will not affect the thickness or internal surface. Okay,
right.
Okay. I think someone else also wanted to ask a question.
স্যার আমি যেটা বলতে যাচ্ছিলাম, ওই এটা তো টিউব তাই না, তা আউটার শেপটা এটা কিভাবে আসবে? এটা কি আরেকটা ইয়ে থাকবে নাকি, ওই ক্যাভিটি বা
this mandrel is continuously, right?
হ্যাঁ, এটা তো ইনার হলো হচ্ছে তাই না, আউটারটা স্যার?
আউটারটা এই যে এখানে সেটাই তো বলছে, if you look at this, the air temperature, volumetric flow rate, and drawing velocity determine the diameter and wall thickness of the tubular cross section. এই সবগুলোর কম্বিনেশন, এই সবগুলোর প্যারামিটারের উপর কিন্তু হচ্ছে তোমার ডিপেন্ড করছে যে হচ্ছে এক্সটার্নাল থিকনেসটা কি রকম হবে।
মানে অটোমেটিক বাইরেরটাও এইভাবে চলে আসবে টিউব আকারে।
And for your information, the outer surface will not be as smooth as the inner surface.
আচ্ছা।
Then there you must have to clean the outer surface and do the grounding and other polishing things. Okay? And also when you do the annealing, after drawing you always need to do the annealing, right? When you do the annealing, then it becomes much more uniform. Okay. Okay, any more question? So what time is it? Okay, I think I'll stop today on this slide, and we'll continue from the next day, since it's been almost 1 hour. The forming of glass fiber, how to make the glass fibers. There are two categories. Okay, fibrous glass, that means irregular arrangement of glass fibers, and these are basically used for thermal insulation, acoustic insulation, air filtration, and other thing like this. And second one is the long continuous filaments. That means আমরা যেটাকে দড়ি বলি, লাইলনের দড়ি সবাই হয়তো দেখেছে, যে ইয়ার্ন যেটাকে বলে আর কি। To produce yarns, we can use the glass fibers, which is made of pure glass, okay, and also optical fibers. Okay, the different production methods are available for manufacturing this. There are a lot of production methods actually. Nowadays, it is still people are still trying to develop new methods for manufacturing this kind of fibers to produce continuous crystalline fiber, non-crystalline fiber, then in amorphous fibers. There are a lot of works actually going on this kind of fiber manufacturing process, and different production method, and we'll actually discuss two methods in here for each product category. First one is centrifugal spraying. It's a very simple process. Okay, you put the molten glass in a container where you have holes on the periphery of this container. You rotate this container, and then due to the centrifugal action, through these holes, glass comes out continuously. Okay, continuously glass comes out with the pinholes, and then you use the high velocity air blower for cooling. Okay, and then you use binder to put because why we use binder is that when these fibers are getting into the surface, then we need to bind them together. That's why we use the binder, and to curing oven, at the curing oven they becomes solidified, and this process is used for to produce the fiberglass mats. Okay, to produce fiberglass mat, not the continuous fibers. Okay, these are random fibers. Sometimes some fibers get separated. It's not kind of continuous. Okay, any question? মানে অনেকটা মানে কোন একটা বোতলের মধ্যে চারপাশে ফুটা করে দিলে চারপাশ দিয়ে হচ্ছে লিকুইড বের হয়ে আসে না, অনেকটা সেরকম টাইপের। কন্টিনিউয়াসলি রোটেট করা হয় যাতে ফাইবার গুলো একটা আরেকটার সাথে পেঁচায় যায়। ঠিক আছে, পেঁচায় গিয়ে এই ফ্ল্যাট সারফেসের মধ্যে পড়ে যায়। ওকে, এটা হচ্ছে বেসিক প্রডিউস দ্য ম্যাট। এবং এই নিচের যে ফ্ল্যাট সারফেস আছে, এই সারফেসটা হচ্ছে কন্টিনিউয়াসলি মুভিং। এখানে যে তুমি কি রকম থিকনেস চাও সেটার উপর বেস করে এই কনভেয়ার বেল্টের স্পিডের উপর ডিপেন্ড করবে কি পরিমাণ থিকনেসে তোমার হচ্ছে ম্যাটটা তৈরি হবে। ওকে, okay, any question? And next one is the continuous filament manufacturing. In the case of continuous filament manufacturing, the continuous fibers of a small diameter, very small diameter, like diameter is 0.0025 millimeter. Okay, to produce the glass fibers, we use this method. And in this method, we use a small orifices in the heated plate. Okay, molten glass stays in here, and there are some orifices like with the diameter something like that, 0.025 millimeter or 0.0011 inch. This kind of orifices available in the hot plate, and glass flows through these orifices with the help of air pressure. Then these materials are sprayed with cold air to get solidified, and once solidified, they are collected into the reel. Okay, it's a very simple process. জাস্ট হচ্ছে মোল্টেন গ্লাসটাকে একটা কন্টেনারের মধ্যে রাখতে হবে, যে কন্টেনারের বটম সাইডে এরকম কিছু হোল দেওয়া থাকবে। এই হোলগুলোর দিয়ে যদি আমি গ্লাস ম্যাটেরিয়ালকে পাস করার সুযোগ দেই, যে কন্টিনিউয়াস স্ট্রিমটা বের হবে, এই স্ট্রিমটাকে যদি আমি একসাথে টাচ হওয়ার আগেই কুল করে ফেলি, তাহলে সে আর একটা আরেকটার সাথে লেগে যাবে না। ঠিক আছে, তাহলে ইন্ডিভিজুয়াল ফাইবার আমরা এখান থেকে এক্সট্রাক্ট করতে পারবো, এবং এই রিলের মাধ্যমে আমরা সেটাকে পেঁচায় নিতে পারবো। ঠিক আছে, কালেকশন পুল, রিলস। এবং এখানে আরো কিছু প্রসেস আছে, যেমন হচ্ছে বিফোর স্পুলিং। দ্যাট মিন্স কোন একটা ইয়ার মধ্যে জমা করার আগে, রিলের মধ্যে জমা করার আগে, fibers are coated with various chemicals to lubricate and protect them. For the protection of the fibers, we can use the lubrication. And drawing speed of around 50 meter per second. প্রতি সেকেন্ডে 50 মিটার এরকমও হতে পারে। And the distance between these two, we can see here is very small, but it's not that small. Okay, it's kind of long distance. and that's why you can use a huge amount of speed like 50 meters per second for drawing this glass fibers. And in between these two lengths, we have to pull it down. Okay. So today, I think.
স্যার এই ফাইবার গুলো আসলে কি কাজে দেয় আসলে অ্যাপ্লিকেশন গুলো?
ফাইবার গুলো দিয়ে হচ্ছে
সূক্ষ্ম ফাইবার
রূপ তৈরি করতে পারো। ফাইবার ম্যাট দিয়ে হচ্ছে আমাদের যে ইয়াগুলো আছে না, কম্পোজিট ম্যাটেরিয়াল, গ্লাস ফাইবার রেইনফোর্সড কম্পোজিট ম্যাটেরিয়াল তৈরি করার জন্য এই ফাইবারগুলো ইউজ করা হয়। ওকে। এয়ারোস্পেস যে স্ট্রাকচার গুলো আছে, কিংবা হচ্ছে আমরা খুব রিসেন্ট এক্সাম্পল যদি আমরা বলি, সেটা হচ্ছে আরএফএল এর একটা প্রোডাক্ট বের হয়েছে না, নৌকার মতো স্পিড বোট বের হয়েছে না, কিছু নৌকা এবং করতেছে, ওরা কিন্তু ফাইবার গ্লাস দিয়ে হচ্ছে এইগুলা বানাচ্ছে। বুঝতে পারছো?
হ্যাঁ।
তো আজকে আমি এই পর্যন্ত থাকবো। নেক্সট ক্লাসে আমরা বাকিটা কন্টিনিউ, খুব অল্প বাকি আছে বাট আমাকে একটু যেতে হবে, এই জন্য কি আজকে এই পর্যন্ত রাখতেছি। আর আমরা নেক্সট ক্লাসে বাকিটা শুরু করে আমরা দরকার হলে অন্য সাবজেক্টে অন্য টপিকে চলে যাব। আর 20 তারিখে তাহলে প্রেজেন্টেশনটা হচ্ছে, ঠিক আছে?
জি স্যার। আর নেক্সট ক্লাসটা কবে স্যার আপনার?